Hi everyone. Oh, snap. I don't have something to clean my glass. But that's fine. Yeah, so this is, first of all, hi everyone. My name is Zach, and I'm an embedded systems engineer. And yeah, I try and learn things live, online, so that I can learn with others. That's really the premise of this stream that you're watching right now. Cool. So let's get to what I wanted to do today. So we've tried this before, but the internet was pretty bad, so we didn't manage to go for it. And so what I want to do today is I want to walk through the documentation or the setup guide for this piece of hardware that we use at work. And the piece of hardware that we use at work is a Tinyclunx33. It's an FPGA. It's an FPGA development board. Its main purpose is to serve as a MIPI to USB bridge. And what I want to go through today is how it works, what to set up with, and it's basically the open source parts of it. See if we can get them explored and maybe get some video going. Maybe see what we can do with it. And just as I said that, I recall I need cameras to use this thing. So let me see if I can get a camera as such. Yep, that's okay. That's good. I need cameras to use this thing. That way we have everything we need. Okay, cool. I think that's good. I'm gonna look at my OBS and see if it's streaming right. That looks good. Okay, cool. So let's get started. I'm gonna start from the top again. I know if you've watched me before, I've probably done this, and you're gonna be like, "No, but we've covered this already." I'm just gonna cover it from the top again because the last stream wasn't so good, and I think this stream is better, and we already have better internet, so this beats the last stream. And I'm gonna go from the top, and the plan for today is to just learn about this piece of hardware. Maybe even run some software on it if we can. Maybe do some building, some running of software on it, and just explore what it is and where is it used and for what reason, for what purpose and such. So let's actually begin with the definition of it. It's a MIPI to USB bridge. So on one side, you've got MIPI, say coming from a camera like this. With me here today is I have a Raspberry Pi V2 camera, which is a IMX219 camera, and then I've got an adapter board there, CZG adapter board that hooks up onto the development kit, which in turn has the FPGA board on it, and then basically you've got data coming in from the camera, and then goes into the FPGA board, and then we do have a data we have a data USB out, which can broadcast USB messages. So, but let's just go through it, and we can actually use the documentation as a good guide and as a help for us, so that we can just walk through this thing and explore it and see where we go from. And if you have any questions or such, you can please feel free to leave them in the comments. I do have the links to whatever I'm working on are in the description, and we'll see from there, basically. And I'll try and stop every now and then and look at YouTube comments and make sure that I can get all the I can cover all the questions and such, basically, is what I'm saying. I'll try and look at YouTube so that I get questions, and if I get a chance, I'll look at Discord as well. So let's actually go through this. Let's start with the documentation, build up slowly, see how long it takes. I have a bit of time, and I'm going to focus on this for a bit because this is going to be quite beneficial for myself as well. So yeah, this might be a long stream, but it should be a fun stream because we're going to explore something unknown all the way to sort of making it known. So let's read through the documentation, maybe, basically. This is welcome to a day in the life of a software engineer working with Tinyclunx. So the Tinyclunx is a module built around the Latttice Crosslink U-NX33 FPGA. It has up to 14 MIPI lanes, featuring native USB 3.2, so that's 5 gigabits per second peripheral, and it's capable of transferring application data at 3.4 gigabits per second at less than 200 milliwatts. That is ridiculous. That is ridiculous low power and ridiculous speeds that you can achieve with this thing. The Tinyclunx system on module is a module that you plug into the dev kit. So that's the thing. Let's start there. So this module over here, this system on module, SOM means system on modules. System on module. So system on module is like a collection of, you get there you go. You get RAM, you get computing power, you get buses, you get processor, you get power, flash, and SRAM, and sort of, and all of those go on one chip, and then you can use this. And then there's SoC, which is system on chip, and system on chip is system on chip. What does system on chip mean? So SoC is going to be the processor, likely. Our SoC is a RISC-V processor, but it's soft core, which means it's written in. We write our processor in RTL, and the processor itself is here. Tinyvision GitHub. Let's look at it. Tinyvision AI, and then I think it's spinal HDR. So our softcore processor is on here, and this is basically RTL release of a RISC-V. I think it's a Vex RISC-V processor, which is written in Scala or something. Vex RISC Linux. Yeah, Vex RISC-V. So yeah, this is basically the processor that we're running. It's a soft core processor, but we'll get to this. The more, I'm just jumping through stuff, but we just, But so what they mean here is it's a system on module. This part is a system on module, and this bigger board, this bigger base board that the small daughter board is sitting on is dev kit, and it gives you a complete implementation of MIPI and USB protocols, and we can handle one chain or one sensor or several sensors through MIPI, or even through not MIPI, as long as it's either I2C or SPI or ADC, whatever peripheral it comes into, as long as we can make drivers for it. Our soft core processor is at the moment running Zephyr, but I'm sure one can use it to run something else and such. So that's open. So let's actually say something like, first of all, let's get this part out of the way. You can buy this from, there's a store here, it's linked, and then there's schematics to the board. There's lots of this. We'll cover this just shortly now. And then there's also a Discord community built around this, and all the offerings that we do, and you can get to that and stuff. So let's actually just get started and see what happens, what needs to be done. Okay, so once you get here, I think you go into application notes, and then I want to open this so that we can go fast one by one. So first slide, this application notes covers the step-by-step to get the Tinyclunx33 dev kit running for the first time, as well as debugging in any case you don't get video with the dev kit. I'm kind of sure we won't get video because I'm running a custom softcore on it, and the softcore that I'm running right now does not have USB, so I'm pretty sure we won't get video. But let's just walk through this, and then the more we build through this, the more we kind of cover stuff. We'll find out stuff. I might even actually look at YouTube for questions. questions on YouTube so far. Okay, cool. But if anyone has any questions, please feel free to ask them. So cool. First steps. The first step here is we're going to set up the hardware so that we can use it. And the Tinyclunx dev kit is shipped with a pre-flashed FPGA bit file and a Zephyr image. To get started, you will need to power on the dev kit by connecting the USB cable to your computer and the dev kit. Before you do this, however, we recommend a few applications be installed. And I'm not going to install this now, but if we look at the dev kit documentation, it's going to be. Oof. Yeah, I have a thing. Let me file that bug, please. Clue. Okay, cool. So let me file that bug, please. Let me file that bug because it makes no sense that we just keep doing stuff without filing bugs. Bring up documentation needs, and I wonder if I've covered that there. Okay, so this link is broken. Is that the one that goes devkit? Yeah. Yeah, let me. What if I do that? Yeah. So why don't we just actually change it? Why don't we just change it now? Why don't we just change it? Why am I gonna build a? Do I write an issue or we change that? I think it's easier if I just change it. Let's just change it now, and then so that other people can actually use this thing nicely. So Tinyclunx, and then I want to go into docs, and then I want to go in docs. In docs, I want to go to application Fastlight probably, and I think if I edit this, I should be able to edit from here. Oh my word! I do have a fork already. Anyways, it's fine. We'll fix that later. Here, let's copy here. I apologize for me being all over the place today, but bear with me. This is sort of how I work. Yeah, okay, it's already covered here, so I'll fix that later. So this link is just broken, but if you click it and you just remove if you click this, it will give you a broken link. And if you just look at the URL and remove the repeated part, you'll get this. So that's cool. We'll see that just now. For details about the dev kit hardware, perhaps we should go through that dev kit hardware before we go on with this, and then it's easier. So cool, let's actually go through that. So the dev kit hardware, as you can see here, as demonstrated here, this is this board, but without the SOM on the middle. And this board just enables us to be able to do development on it. And the current, there's two versions of this. There's this first one, it's called a Rev 1, and then there's this second one called a Rev 2, and that's the one I have. You can see here, version 2.0. And I think the last time we covered the pins, so I can just quickly run through them now. On the top, so I'll use this as the orientation. On the top right side, I guess you're seeing there's a 5V, there's an enable pin, there's an AON out 5V, and then there's a lot of GPIOs that are exposed here. There's GPIO 4 all the way to GPIO 0 all the way to GPIO 7, and then there's an I2C exposed here, which is, we can see here there's an SDA and an SCL, and then there's it looks like a ground part that's exposed as well, so for debugging and such. And then on the next second bank, on this bank, there's three such banks. On the next bank, there's also GPIO G1, B1, F1, and then analog out 5V, analog on out, analog O interrupt, and then there's ground and VDD and 1.5V, and then there's pins here that are going to the flash, so the onboard flash, and I think the onboard flash, we'll find out this. We'll find this about we'll find out about this quite soon. So there's pins here that are going to the onboard flash that you can use for debugging, I guess, and you can kind of sort of like probe them and see what happens and such if you're trying to build a driver for. Because remember, we provide this as hardware, and then there's a few components that you can add on to this that you don't actually have to use them as provided from Tinyvision. You can actually write your own components and be fully supported to do that. It just depends on what you want to achieve. But then some things will be difficult or more harder to implement if you're just doing them without support from Tinyvision. So that's fine. We'll find out. So that's basically it. So for details about the dev kit hardware, we've seen that. So first of all, we need to connect the MIPI camera to the adapter board. This is another thing I did not cover. So let's go back here and we can go order online, and then we can see some other parts. So there's a few parts to this. There's a Tinyclunx system on module MIPI to USB connector. Yeah, that is the whole system, and we'll get to this image later. And then there's the developer kit, which we've looked at, and then now there's a dual MIPI adapter. That's the one I have. There's also a single one, and there's a IMX219 camera, which is what I have here, which is what I have here. Marvin says he wants this board. Marvin, you know when to get this. You know where to get this board. You know what you need to do. I think you know you owe a driver to this board. So do your job. You might get the board. Anyways, sorry, Marvin. I'm making fun of you. Cool. Yeah, everyone meet Marvin. Marvin meet everyone. And Bartholomew might be here. Nathan might be here. Award might be here. A few fun people might be here right now. I don't know who else is here. But yeah. And I don't know who else is here from the Discord or from LinkedIn. So I don't know. That's cool. That's amazing. Okay, cool. So let's do the first thing. So I do have the camera. There you go. And I have a flat FPC ribbon cable. Okay. It's a flat panel connector or something. And we're gonna like hook all of this up and try and follow the guide and see if the guide actually works out. So cool. So what does the first slide do? Connect the MIPI camera to the adapter board by carefully inserting the flex cable into the connector. The blue side of the flex cable should face away from the board on either side of the board. Cool. So when they say on either side of the board, the dual MIPI one comes with two MIPI lanes. Two MIPI connections, not MIPI lanes. Don't count me on that. Two MIPI connections, okay? And what they're saying here is we have this blue color and blue accent on the flat ribbon cable, and I'm going to hook it up like the guide says. I'll scroll it just a little lower so that you can see what the guide says. Yeah, so I'll just connect it and I'll show you guys it connected, but I'll just do it the same way they're doing there. Cool. I have to be careful and do it again properly. Amazing. So there you go. There you go. That's what they mean. So the blue one, the blue side of the cable is facing away from this board that we're connecting onto. And then on the other side of the cable is a IMX219 or a more colloquially known as a Raspberry Pi camera version 2. I don't know what the version 1 is. I think it might be even the Pi camera, but I'm not so sure. So cool. Check the jumpers on the dev kit to ensure that the jumpers are correctly installed as shown in the picture below. So that's basically this. The first time I saw that documentation, I was very confused by the term jumpers, but really it means this is a jumper wire. It's just manufactured. It's just a fancy jumper wire, but this is a jumper wire. So cool. That confuses me every time because I need to. I'm like, whoa, is there like some? When you say jumpers, I'm looking for like jumpers like this, and I wanna remove like a connector and move it, but this is also jumpers. And then they say connect the MIPI adapter board to the dev kit by aligning the connectors and gently pressing until fully seated. Okay, cool. So there's adapters on. If you go back here, should I go back? Yeah, I had this open somewhere. Yeah, there's these adapters, okay? There's these adapters. And these adapters, this one port A and port 1 and port 2 here, and for version 2 it's port B and port A. I'm gonna use port A. Okay? So they also have like this accents on the side, and these accents need to match up with this oh crap. Yeah, these accents need to match up with this you see there's this stuff, but the good thing is it's there to foolproof stuff, so and you basically won't be able to connect it wrong, and that's pretty cool because it'll go no, it won't just fit. Okay, cool. So I'm gonna press it in and connect it. Amazing. Hooked up. Boom. Shakalaka. So that's already on. Let's keep going. The dev kit has two USB-C connectors, one labeled debug and the other labeled data. The debug connector is used to program the FPGA and is not required for the initial boot process, and it also presents an additional serial port that is hooked up to the RISC-V processor in the FPGA for boot, as well as a Zephyr shell. The user connector can also be used to power up the dev kit. So when they say user connector, is because here I should actually change that. So you see on version 2 it's data debug, and then on version 1 it's data debug. Oh, okay, cool. So data is considered the user one, basically. I thought the nomenclature would have changed, but it's fine. The user connector can also be used to power up the dev kit and will enumerate as a super speed USB device. Super speed USB is like USB version, that's version 2 or version 3? Super speed USB. What is super speed USB? I'm just looking up somewhere from a conversation I had with Joshua. What is super speed USB? Is that what version of USB is that? Version what? Super speed is USB 3. USB 3. So USB 3 is what we. It says this is a MIPI to USB 3 bridge. I should have known. So the debug connector is used to program the FPGA and is not required for the initial boot process, and it also presents an additional serial port that is hooked up to the RISC-V processor in the FPGA for boot, as well as the Zephyr shell. The user connector can also be used to power up the dev kit and will enumerate as a super speed USB device. So I don't use Windows, but if you use Windows, you have to install all of that and make sure it works that way. But on Linux, we don't really require anything, and I won't have video, unfortunately. I won't have video, but I can probably build a video up and deploy it. Let's do this. Let's actually try and build a video up so that we can get into questions and start jumping through this documentation. I think that's much better. Yeah, rather than walk through the documentation, let's try and set up a beginner's thing. Anyways, while I do this, while I set up my environment, does anyone have any questions so far? In the meanwhile, I need to decide what I need to do. So I need to, first of all, cd Tinyvision. I have a Zephyr workspace for this, and then I'm gonna go source .vn bin activate. Cool. And then what do I want to do here? I probably already have some software on it. Let's dmesh sudo dmesh w. Let's actually just watch. Let's watch that, and I'm gonna plug it in, and we see what gets connected shortly. So let's look. There you go. Cool. So new high-speed USB device. Okay, yeah. So high-speed is it's on the side and then it says it's a Tinyclunx dev kit, and it's registered a new USB serial, and so I probably have USB CDC on this on TTY USB 0. Let's see. I'm gonna try and see Control R screen. Yeah, and then I wanna go USB 1. USB USB1. And then if I go blah, 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 blah. So that I don't have anything there. Let me try and actually build an app and see if I can build an app and flash one. So where's build Tinyclunx firmware or Zephyr, something like samples, USB CDC row. Oh yeah. No, I need to tell it with board to build for. West build. Yeah. So instead of building that, I want to build Tinyclunx33 Zephyr samples USB CDC USB CDC row. Can I do that? And by the way, the application I'm building exists online and it's here. GitHub. It's gonna be it's shipped with our with the Tinyclunx SDK, and that lives Tinyclunx33. It lives here. So this is where the SDK lives. And what I'm building right now is this application. If you go into Zephyr and if you go into samples, I'm building USB CDC row here. And obviously it was built by Joshua. Surprise, surprise there. Let's see. So let's have that building. While it's building, do we have any questions so far? Any questions so far? You can ask anything. I mean, about Zephyr and stuff. You can also ask me about me, but I don't know if I'll tell you that. Okay, cool. So that's built. And then I'm going to do something like West Flash. And I'm just going to hope that I'm running the correct thingy-majiggy. And I'm going to try and do like reboot. Okay, cool. So that's a problem. So something's not working. Where's my clock selector? Clock should be on 60 megahertz. It doesn't say done, so that's a problem. Clock is on 60 megahertz. Do I need to maybe I need to just unplug it and plug it in again. This is the problem of and what do I say? Control A, K. Yeah. This is the problem. Sometimes we're just a bit of a ways off and then it doesn't work. Let me get a working call and then I'll flash it. In the meanwhile, please, let's ask questions. Let me get a working call from work. A working soft call processor that we can use. I want to see my threads. Just give me a moment. I'm going to find this now. I just want to see my threads now. I just want to make sure I get the right working softcore, because there is a softcore that works and I'm going to make it work. That's fine. Yeah. Any questions so far while I look for this core? I usually have it. So easily. Where did Justin give me that core? Justin gave me that core. Justin gave me that core and I don't see where it is. And I don't know where I kept it, so I can't just go on my computer and use it. I'm looking for an RTL core that will run this thing properly, and I so far can't see it. Just please bear with me as I look for this thing. I can also build one. Well, first of all, but that's 1.2. I want a 1.1. I want a 1.1 that works with the version of the board that I want to show right now, because I want one that works with USB so that I can actually do the stuff I do. Yeah, just hold on for me, please. Hold on. It might be here actually. Please hold on for me. Yeah. Okay, cool. So I'm not seeing that one. And this is MCU bootloader port, probably. What I was working on recently. Yeah. J. This is not cool. This is not cool right now, so just bear with me. So I know there's an issue that I'm trying to sidestep. There's a few versions of our RTL, and one of our RTL versions expects me to be using the external clock, and the other one expects me to be using the internal. There's an external 60 megahertz clock, and the other one expects me to be using the internal PLL. But I don't know which one it is. And the RTL is quite huge, and I haven't learned the RTL enough to be able to go and so let's see this. This is a Spinex one. Sure. I don't even remember how to put it in. I don't even remember. I need a proper one. Oh, that's a shame, man. That's a shame. This is a shame. This is a shame. It's a great shame that I can't find what I'm looking for. Oh yeah. Yeah, I found it. Oh yeah, I found it. Oh yeah. Oh yeah. I'm gonna get it just now. Awesome, awesome. So let's do this. I found it. I found it. Please excuse me. Documents. I'm gonna save it there, and then I am now gonna flash it. Okay, let's flash this new one. CD. Okay. CD. Documents. I think something like Tiny AI, and then something like Spinex. And I'm gonna do ECPP ROG dash K 1, I think that's a thread, and dash O 0x 200 123, and then oh wait, I want to flash a custom bit stream. That's the first part, and I've forgotten how to do a custom bit stream, so I'm gonna look at the documentation and see reference design. Yeah, they should give me a way here of doing it. They should tell me how to flash that. I mean, I can go to Tinyvision Zephyr SDK. I think that was public. Was it private? Is it private? This isn't locked. Yeah, so it's not locked. And then I want to go to issues, and I want to go into closed ones, and I probably have one here. No. I'll have to check on this side. Flash. Right. Yeah, sorry. This is an internal issue that I have to look at, so I apologize. Yeah, cool. I found out I need to do it. So cool. ECPP ROG, and then I'm gonna point it at dash. Let's do it here. I can't show you the issue, but I can show you what I need to do. 0 1 2 3 1 2, and then I'm gonna go like reference designs by directional demo bit, and then that should actually be good. So let's just flash the new CPU in. This is I'm flashing a soft-core CPU that works with a 60 megahertz clock, and that I should be able to use with does it expect 1.1 or 1.2? I don't know. Anyways. Okay, that's fine. I'm gonna do that now. I hope this is not a public. This should be a public thing, yeah. I really hope I didn't just do private stuff. This should be public archive. Cool, fine. So there you go. So that's it. We have a softcore that is on, but what I need to find out is where to, if if at all. This is a 1-1. Okay, cool. I can build for 1-1 then. So I can build for 1-1. I can go back here, and I did build for 1-1. Yeah, so we can do just west flush now and see. Yeah, cool. Now I'm gonna unplug it, plug it back in, and that should go like, it should go like, yeah, that's good. And then in here I should be able to do that, but that's not gonna help me. Okay, cool. Control A, Control K, Control AK, yeah. And then there's that, going to 1, okay. Doesn't work, does not work. This is the problem with working with FPGAs. Sometimes you do not know what hardware you're running, and because you don't know what hardware you're running, it becomes flash debug. Yeah, Zephyr. It becomes a little bit difficult to tell. So it's okay, but it's okay. So I want to go into So I want to go into go back. ls cd flash debug. Yeah, ls, and then there's a ls. What's that? But flash the Zephyr bin, and then I want to flash this Zephyr bin so that I can actually ECPP RG and then -k 1 -o 0x2 1 2 3 1 2. I should be able to, and then I should be able to do a Zephyr bin. Let's see if that actually fixes anything. It would be a shame if I can't get output out, but we're gonna learn stuff. We're used to this by now. Failing means nothing. Failing means only learning where it doesn't work. Okay, cool. So, and then I'm gonna go. Oh, nice. Cool. There you go. We have something. So, oh no. Device list. So there you go. We have we have devices. We have an interrupt controller. We have a UART. We have a serial. We have an I2C. We have a disabled PLL. We have a I2C expander. We have USB that's ready and it's running Zephyr UDC, and we have Zephyr CDC ready as well. And yeah, so that's cool. So we've got something running. And the UART is obviously broken. So, but the problem is, how come I cannot run my own? How come I can't run this? This is a 1-1. That's the samples. USB CDC row. Let's actually go back. What other samples do we have that we can run? Minimal. CDC mute, CDC row, CDC shell with MCU boot. Am I on a funny branch? I might be in my own branch that Tinyvision ls branch git checkout main git pull. Okay, cool. So now we can actually go back again. We can go back again, and we can try and build a version of some firmware here. So we see. Yeah. So this is actually not going the way I expected, because I expected to be able to get to running camera apps, which I might be able to. I might just need to go and run them from from 1.0, our former version from Latttice. And Latttice is this SoC that is provided by Latttice. So I might have to use this. I'm trying to use our in-house. So there's this SoC. There's this SoC that is provided by Latttice, and it's just yeah, this is an SoC. I might go back to using this SoC. Yeah, there you go. I might go back to using this SoC rather than our in-house SoC, because our in-house SoC is still under development, and there's a lot of work that's done when those things happen. West Flash. I want to see if we can get West Flash working. And I think that was CDC row, and yeah, that's okay. So I'll come back here and I will just press both of them. Disconnected, connected again, and then I'm gonna try that. So somehow I cannot get, and it says done too, an A3 and 5 volt and 3.5 volt. Somehow I cannot get the clock selector, the application to run. Perhaps I should change our clock to the default one and see what happens. Go inside. But no, I'm using the one that depends on the 60 megahertz external clock. And that's not working. But this should work. Somehow it should work. I need to ask a question. I need to ask Joshua a question, or someone at work a question. I'm just thinking what to do, how to fix this. No, it's okay. Can I go 1.0? But I would need a 1.0 release. Where can I get a 1.0 release? And would a 1.0 release via CDC UART, would it allow me to just run on any? I should be able to get a 1.0 release. Just a moment. Let me just do a shot at work. Just a moment. I'm trying to get a release. Okay, cool. So I found some releases. There's some releases here. We can use these releases. And I'm gonna try and use this one, I think. Let me try and use this one. I'm gonna pull this down, and I'm gonna put it tiny, and I'm gonna put it in. We can put it here. Save it here, and I'm gonna try and flash it. I'm gonna go back to the internal clock. And then I'm gonna try and flash it. I'm gonna try and flash this one. Let's try and flash that one. Yeah. And instead of reference one, we're gonna tab. Okay. CD Tinyclunx, and then we wanna go do this. Tinyclunx. That's fine. Let's try and get that one going. Okay, cool. We're gonna try with any RTL and see how it goes. Okay. Any questions so far? I have more questions than you guys probably, but let's see. Okay, cool. So there's that. I've done that, and then I need to go build yeah, let's just build CDC row, but we wanna build it for 1.0. And then let's actually see what happens. If I get a corrupted feed, that's good because it's still working. That's fine. And I might get a corrupted feed because this needs custom baud rate. West should know where to put everything. Yeah, it's putting it in the right place. Cool. For 1.0, that's fine. If 1.0 works and it's just working, then we just stay with 1.0 and stuff. Yeah. That's actually quite sad. That is quite sad. What if I just disconnected and connected again? Okay, cool. So I sort of need to go back and okay, so it looks like 104 actually messes up, so let's try with 103. Let's try with 103. See. Okay, cool. And then we have here, we can actually ban that one, 103. flash that again. Flash CD0 again. Cool. And then I want to go here and I want to do something like that. Please give me some garbage. Oh, this sucks. Okay, so here's the problem. Whenever your hardware becomes configurable, it becomes very difficult to know which hardware is running. And I don't want to run a client's hardware because usually the client's hardware runs, but those are like internal things, and I would rather not do that. But it's fine. We might as well do that. Might as well do that because it's not working now. So let's actually do this one. I found another one. I'm gonna save it, and this one is a 60 megahertz one, so I'm gonna save it, and then let's see. It's a client one, but let's see. Let us see. So first of all, we wanna I know this is a 111, yeah, so this is fine. So what I want to do first of all is I want to flash this new RTL. I think, yeah. 1, 2, 1, 2, 3. Yeah, let's flash this new one. And I know this is a 111, so hopefully at least this one just gives us something, some sort of output, and then we can kind of go on with that. I'm a little frustrated at the moment. I know no one has questions because I'm yet to do something coherent. My sessions are usually very informative, but I don't know that this one is one of those. So everything says to give up right now, but I don't want to give up. I don't like giving up, so I'm gonna keep trying. Sorry. Cool. So that's actually flashed in, and I'm not selling. I'm not giving out any sort of information there. And what I want to go back is cool. So if I do this and I want to build that, but I want to build it for 1.1. Let's see. I'm gonna build this one for 1.1 and see what happens. Any questions so far, people? Any questions so far? Must be confused as. No, I'm basically, I'm just basically debugging my work at here. I'm just doing my job online. That's what I'm doing now. I'm not even doing any. I'm not even making any entertainment. I'm just doing my job online. Let's see. Cool. So there goes that, and I can just go here and. Let's try and build a shell maybe and see. Rather than cdc row, cdc tab, cdc shell, yeah. Let's try that. And then if it doesn't work, we'll just sort of give up for today. I think we might have to give up for today, basically. I do not like giving up, but I think we might have to give up. And I promise you it's gonna be such a tiny issue when I come back to it. It's gonna be such a tiny issue that we didn't spot, and then that kind of just messed up everything. But we'll see. It's never too bad. Okay, so there's that, and then I'm gonna do a rest flush. Okay, cool. I'm gonna hook her out, plug her in, and then what I wanna do is I wanna go back here and try and start that and see if I get anything. I don't get anything. Must I try the data port? So let's actually look at the messaging. And I'm gonna try out the data port. I'm gonna hook this in and see if anything enumerates. So nothing enumerates. Okay, so this one didn't work out. This is what I'm saying. And it probably didn't work out because there is some issue that I'm currently unaware of. I've been working too much on the Zephyr side, and I've not worked on the RTL side of this thing for a month at least. And basically what has happened is I have drifted from development, and basically I could not run let's go and look at the clock selectors. I basically cannot run any software on this or hardware. My problem right now is running hardware. Yeah, my DAN LED is being lit. Yeah, I want to look at the clocks. So there's a 60 megahertz oscillator. Okay. So here's the problem. Well, I'm not saying this is a problem. I'm just saying I can't see why it's not. because I am connected to the 60 megahertz oscillator, but I can also just try this one as well. No, but this is an IPK. I don't know how to use that. Video top single tone. Okay, guys. Okay, so here's the thing. Let's do this. I'm gonna have to give up. And unfortunately, this is life. I'm going to have to give up because I need to go back to work and figure this out so that I can come back and demo this properly. Yeah, I'm gonna have to give up. So yeah, I'm gonna have to give up, go back to work, debug with everyone, make sure everything works, and then come back and demo this nicely, because that's my issue now. For sure. Thank you all so much for hanging out with me. I didn't have the stream that I expected today. That was a rather difficult one, but I will see how I can make it better, and I will work on making another one soon. Thank you so much.